Welcome back. Today we are going to solve the poison from Hack the Box. This is a mandatory machine for anyone preparing for the OSCP because it forces you to break the Linux habit. This isn't Ubuntu or Debian, it's FreeBSD. If you rely on your standard Linux commands, then you will fail. In this video, we'll go from simple enumeration to local file inclusion, perform Apache Log Poisoning to get a shell, and finally use the stabilizing our shell to access easier. So let's go to enumeration. So sudo nmap t4, I think just poison I think this is poison, and udp scan. Let's make this like this. Scan is quite fast, so we are going to check this. We can find that port 22 OpenSSH FreeBSD and port 80 Apache web server 2.4.29. So it explicitly states OS FreeBSD and it is critical. So standard payloads like bin bash or paths like var www html might not work. So we need to keep this in the back of our minds as you attack port 80. So we're going to wait. And this status, I think it is about to finish. So I would also like to perform the web enumeration before we navigate to the port 80, the website. I think we need to check the website now. So we have like temporary website to test. I think we can run GoBuster. DRU8P. I think this is the same one, but does not exist. It is interesting. Directory. I think the name could be changed. Not sure. We'll use. I will use this one. It says index PHP, info PHP, and browse PHP. First of all, we need to navigate. I think we can submit the kind of file. This is the result of ini PHP, and when we check like this, it looks like the array. And go back to the main page and info.php. It also says that it is like FreeBSD. And let's check the list file PHP. Browse PHP, index PHP, info ini list files, PHP info. I think there is interesting file here, pwd backup.txt, which looks related to password. This password is secure. It's encoded at least 13 times. I think it is related to password, so we can run the new comment here, and I think sudo by, and we can also create the file here with the paste selection with this. And we would like to decrypt this base64 t. So when we check the file, maybe we can, oh wait, I should use, it starts with this, so we can guess like which kind of encryption was used. Base 64 fixed, and we can shorter base 64, base 64, base 64. I believe it is like related to the base 64, so maybe we can decrypt this 13 times using base 64 decryption method. So first time we can just base 60, just test whether it works as expected. It says invalid output. Maybe we can look into this file again. I think if you like copy and paste on this text editor, I believe text editor, interesting. I think we can just look into the cat result. We have like space, and I believe if we like copy and paste this, I think I can maybe using like this. Yes, I think if you like copy and paste like this, there is like line change, line break, and like the space on this. So we need to the base 64 tool is strict. If it sees a space in the middle of string, it crashes. So first of all, we need to do the cleanup process. So this stands for translate, and this black means delete. We will need to delete the every new line and space, and we will use the temp file, and we will create the loop command to decrypt this 13 times. For I in so to start the line of instructions, and cat temp, like this temp file, and base. So it reads the temp file and decrypt once, and we will save this in temp2, and if the decoding was successful, it will proceed with this $& and copy the content to temp, and if we perform 13 times, then it will finish the process we've done. So we can cat temp. I think this is the related password. we need to save this relative password. So in the meantime, we can also check the port 514 is open based on the UDP scan and TCP scan. And the username could be Charix, like the password used, but we will see this later. And the GoBuster looks like maybe we can check this amount of this at this stage. I think we couldn't check one of our file, which is the php info.php. It also says FreeBSD. So if you look into this structure, it looks like we can perform local file inclusion. So maybe before we do this, we can check like, so we understand that there is also browse PHP. We would like to test this. Browse PHP. The error says it's like warning include. So this is the game changer. If the developer had used file get contents function, the server would only ever read text. We would be stuck just stealing files. But because they used include, the server will execute any PHP code it finds inside the file we point to. This confirms that log poisoning is possible. So we have include capability, which can be used for remote control execution. And we need to find a file we can write to. On FreeBSD Apache, the access log isn't in the Linux location. It is almost always found as /log/httpd-access.log. So before we test our theory, we can try using this file. I think when we check this, there is also the user Charix who can use the C shell because it is FreeBSD. And we would like to check the log that I mentioned, the access log. It says our like record as well. And the string Mozilla looks to be related to our user agent, and we know the user agent is just a text header sent by our browser. We can control it and change it to whatever we want. Because we provided earlier that the server uses the include function, we know that if we change that text, user agent text, to PHP code, the server won't just read it, it will run it. The user agent header is special. Apache usually writes it raw into the log by preserving our text exactly as we type them. So it is vital to understand the two-step processes that I'm going to do. Step 1 is the poisoning. We will use burp suite to send one malicious request. The only goal here is to write our code to the hard drive. We don't care about the response yet. Step 2 is the execution. Once the file is poisoned, we go back to the browser and reload the page to wake up our code. So let's turn on the burp suite here and the burp suite tool as well. So now we perform the actual log poisoning. Think of this technique as setting a trap or planting a landmine. Right now, the log file is just a passive text file. We are going to inject a tiny piece of code that turns that text into an active command console. So first of all, we need to take the request. Oh, where is my burp suite? Okay. Next, start burp. I think we can close. Delete. Next, start burp. So we need to proxy intercept on and take this request and turn off. I have the request intercepted in burp suite now. I'm looking at the user agent header. Think of the user agent like a name tag you wear to a conference. The server blindly reads your name tag and writes it down in its guestbook, the log file. Normally it just says like Mozilla 5.0, but I'm going to take a marker, cross that out, and write a PHP backdoor on my name tag instead. So delete this. First, the PHP tags. Without these, the server just treats the logs as a text file. These tags flip the switch, telling the server, stop reading text and start executing code. Second, the system function. We use this instead of execute function because system passes the command to the OS and prints the output back to the page. If you use exec function, execute function, the command would run, but you'd be blind. You would not see the result. Finally, the last one. If we by using this, we can create a dynamic variable. So it tells PHP, look at the URL bar, find the letter C, and run whatever command is next to it. So this effectively turns the log file into a permanent universal remote for the server. We poison it once, and then we can run infinite commands just by changing the URL. So we can send a request. I send the request, the server responds 200 OK. The trap is set. To the server, it just wrote some text to a file, but to us, we just embedded a dormant virus waiting for a trigger. So we can find this. So let's the URL will look like this. duplicate in case. I think it is. I think maybe due to perf suite now. Not sure. Maybe we can just turn off. So info.php and ampersand. I think we also need to check var log HTB. So if we check this, I think our go booster, like due to our go booster maybe. Interesting. Still running? I don't think so. I think we need to wait to retrieve all logs at this time, because like I believe like GoBuster recorded a lot of logs here. I think we can test this once again. See. I'm not sure why I cannot have the latest log. I think it got stuck. I think I would need to reset this. I think something is we will use this IP address, and I think we also need to purposely change this. Maybe I can just intercept this from the beginning. Why is it not working? And send to repeater and copy and paste and turn off this and send and search this and r perfect. We can see like UID, GID groups or something like this. This looks to be related to our ID command. So if you look into this, like the file var log HTTP access log, this is the key. It tells the server's include function to open the log file door. Once it opens that door, it reads our name tag, the PHP code. So this is the command. Our PHP code wakes up, look for the C variable, and execute it. So we have successfully turned a static log file into a dynamic remote code execution engine. Now we just need to swap out the id command for a full reverse shell. Since this is FreeBSD, standard bash shells usually fails because bin bash often doesn't exist. We need a payload that uses bin. We will use like bin sh, or we can check bin csh if it doesn't work. I will remote shell creator generator. Yes. Our port is 10.10.14.51 and 9001 and bash. I would like to use this encoding URL encode. And instead of this, I can like send before we can set the clear oh wait, I think I create another. Okay, just then and execute. So we have used the standard netcat mkp4 payload. So we can check, like we like to elevate this shell, so python c import pty sorry, I think I need to do again. Where was the command? Copy and this again. But we can find that the Python file with Python it doesn't look like the Python exists, so we would like to elevate this shell nevertheless. So first we would like to run this command, user bin script quiet mode, and we don't want to save the recording card, and the shell we want to launch. Perfect. The prompt changed to www and poison. It works at sign and poison, I believe, and we do the standard stabilization process, Ctrl Z. So it backgrounds the process so we can talk to our local Kali terminal at this stage, and this tells Kali pass all keyboard shortcuts to the remote machine, not the local one. Enter multiple times and export term. I think export command not found. So based on FreeBSD, we need to use set environment like this. Perfect. So yes, we can use this command as well. When we check the in this path that we have seen before, there is Charix user, and there is the password which looks related to Charix. So we are going to use this Charix. So Charix password, paste selection. Perfect. We now into the Charix user. So we can navigate ls and cd. I think we need to like this. Cd Charix. There is secret file. So I would like to unzip this. It says passphrase required for this entry. So we may want to use the Charix passwords further. This, and we can specify the credential as well. So unzip -p and this and secret. It says event not found. Even if we try to do it interactively, the unzip utility on this old FreeBSD box is buggy and won't accept our input correctly inside this reverse shell. So we need to use our Kali appliance. So we can check like nc set the listener 124 secret.zip. So we are using a redirector. We are telling Linux don't print the incoming data to the screen. Save every byte directly into a file named secret.zip. So now on the FreeBSD machine, we simply read the file and pipe it to our listener. Cat secret.zip. So cat reads the raw binary data of the zip file, and pipe passes the data to netcat, and we can check this. And we can disconnect this. I would like to move this secret maybe I can check. Okay. I'd like to move. I believe I also need to specify So we successfully retrieved the secret.zip file. So we can check like unzip secret. It says like secret password. We can use the password here, and perfect. So we can check this file. This was the file that we choose. Now we want to check the secret file. I think the file looks broken, and all we can find could be it is 8 bytes. We have a tiny 8-byte binary file named secret. So we need to find the service on the victim machine that uses this kind of authentication format. So back on the FreeBSD shell, so I like to type this sockstat. So on Linux you use netstat. On FreeBSD the command is sockstat to see what services are running internally that we couldn't see from the outside. And here is the smoking gun. Let's break down this output line by line. So XVNC, this stands for VNC server, virtual network computing. It's a remote desktop service. Port 5901. This is the standard port for VNC display, and the user is root. So this looks important, and if we review the secret file again, the VNC authentication files are notoriously exactly 8 bytes long. We found an X-byte binary file named secret. This is not a coincidence. We have the master key for the VNC session. Second, look at the user column. It says root. This means the administrator has a GUI desktop running. If we can use the secret file to log into this VNC session, we won't just be a user. We will be viewing the root user. We can use the technique called local port forwarding. So SSH the target IP was 1. I think so. If you look into this command, the L means local local forwarding. It finds a port on my machine, Kali machine, and this is the destination. We are telling SSH take anything that walks into the Kali entrance, carry it through the tunnel, and drop it off at the Poison machine's local host port 5901. So I can enter the characters password again. Why it does not work? So we successfully perform SSH tunneling. So I think this layout is better. So we have the secret file which can be used for VNC viewer authentication. So we can, like, instead of typing password, we can use this file and localhost because we have binded the port. And this looks quite classic. Who am I? It says root. So we have successfully compromised the machine by stealing a VNC authentication file and tunneling our way into the administrator session. So Mm, so I hope this walkthrough will be helpful for you, and thank you for watching this.